store the data from XML to XML file and XML to relational table. This two only.
Right.
So okay. So today we are going to discuss about two different transformations on XML type of data. So these are XML parser and XML generator transformation. So one is for to generate the XML code, source code, and one is for to read and to understand the XML source code. So both are different. So clearly observe here. Actually, I'm going to create one mapping to store the data from one XML file to another XML file. Between these two, I need to create two different transformations of XMLs. So XML parser and XML generator. So just check whether how these two are working. So create mapping, map underscore. For example, here XML transformations, parser and generator. These two are the different transformations here. So from here, from source, the book is the XML file, and from target also book XML is there, right? So clearly observe here, I want to create two different transformations between these two. This is XML parser transformation. So whatever, either XML parser transformation or XML generator transformation, if you want to create, you need to select one XML structure. So what type of data you need to transfer through this particular XML parser or XML generator transformation, the type of table or the type of XML file. So based on this type of file structure only, these two transformations will create. Because here the XML transformation or XML file structure is completely different from others. So for example, here if you have a number of XML files also, from each file compared to other file, there is different structure. So no need to specify any same structure here. So depends on your requirement only, you can create the structure. So for example, here the structure means different type of attributes. For example, ID or the title, genre, price, publish date. But here actually we specified a total 7 columns or 7 attributes in the XML file. So for example, if you consider some other different file, so that file are having some different number of XMLs attributes. So for example, another file having some 10 attributes. So based on the number of attributes, the structure should be different. And here catalog and subcatalogs also is different. So based on that structure, the structure should be different, so that we need to specify the structure of the XML file while you creating the XML parser and XML generator transformations. So that is the reason when you try to create XML generator or XML parser on mapping designer, it directly asks about import XML definition. So this is same like importing the XML definition from source analyzer or importing the XML definition from target designer also. So clearly understand here, our XML files book. So of course book or book one, these both are same structures here. So clearly just either of these select one, just open. So the open to override the infinite length of fields is not set. So we want to set it before you import the definition. Yes. Just click on OK. These are all by default options. Next. Here, our available source XML file is an entity relationship model. Just OK. See, this is XML parser transformation. So clearly observe this. In this XML parser transformation, only one data input port. So we have only one input port only, and remaining all output ports. That means it allows single input port. It allows the information from single input port, and it provides the information to multiple output ports. So clearly observe this. Data input this is the input port in the XML parser transformation. It allows completely XML source code. So XML source code is different and XML file is different. So source code, we need to write the source code and save it as a extension with .xml. Then only it creates as a XML file. Understand? So yesterday I showed you already the source code in the notepad. So that notepad, when you save with the extension .xml, then it is stored in XML file. So clearly observe this. So that source code allows data input. The XML parser transformation understands the source code, depends on the structure which creates while creating the parser transformation. So that particular structure, based on that structure, it extracts the field values from the source code. So the extracted data is provided to target through these output ports. That is the importance of the XML parser transformation. For example, in the real time, when you consider any relational database tables, either MS SQL Server database or any Oracle database or any Teradata, DB2, all these are. So we have different type of data types available. For example, if you want to store a numeric type of information, there is a number data type. If you want to store any character type of information, there is a varchar2 data type. If you want to store any date type of information, there is a date or time data type. So these are all the depends on the database types. Data types also different. Along with all these different type of data types, so we have a XML data type also is there. So for example, when you create one table, you need to create one XML type of column also. So then you have to specify just a column name and data type as a XML. So that's it. So this column allows completely XML file information. So that means it's a source code of the XML. So at the entire file source code completely we can store in single file. So single column of the relational database. For example, in that case, if you want to take the information from single column from the relational database table, it provides only XML source code. That code needs to get it through XML parser data input port. So this data input port will get the data from single XML data type column of the relational database table, and it understands the source code, depends on the created structure of the XML parser transformation. So it extracts the field values from the source code, and finally it provides the output to any output. For example, if it is a relational table or flat file or XML file, whatever it is. So it provides to target tables through the output ports of the XML parser transformation. So that is the thing here you have to understand. That is the reason data input is the input port from the XML parser. It is used to get the XML source code from the either from XML generator transformation or from any relational table column of XML data type column. Understand? So here I want to create one more transformation, XML generator. So this is completely reversed from XML parser. This is also created with structure of the any table, any XML file. So this is a book. Just okay, next and finish. See, this is created. See, clearly observe this. Here data output. XML generator transformation provides only data output. It is a output port from this transformation, and remaining all only input ports. That means the data XML generator transformation will allow information from any XML source file or any different flat file or any different relational table, but it provides only XML code only, source code. So that means it generates the XML source code. So by using this XML source code, we can create directly XML file in the target, or we can pass this data to a relational table single XML field. For example, if your target is a relational database table, in the table one column is a XML column. You want to load XML source code completely to that particular column, you need to take XML generator. So by using XML generator, we can generate the XML source code from the source data. So based on the complete, for example, if you have a number of books information in the source different table, so from that particular table you will get the data from XML generator transformation, and it transformation generates the XML source code based on the available data, and structure is created by the generator transformation. So see, clearly observe this. This XML data output we can provide to the XML data input to XML parser. So clearly observe this. XML parser reads XML source code. XML generator provides XML source code. So that is a thing you have to understand here. So source and targets are different. Whatever it may be, that's not a problem. So source and targets are different. So here actually XML files are available for me. So that is the reason I just take XML files here. So no need to take only XML. You can take any relational table or flat file. It depends. So clearly observe this. From here also I can move this. Understand what's happening here? What's going on here? Any doubt? Nothing. Actually here source is a XML file and target is also a XML file. But I want to move the data from source to target. So the XML source qualifier is by default created by source file. Okay, it is used to understand the data from source XML file system. So XML generator gets the information from source XML source qualifier, and based on the structure which created by the XML generator, so it generates XML source code. Here clearly observe, don't misunderstand. XML source code is different, XML file is different, and data is different. For example, data means ID, author, title, generic price, publish date, description. These are the column names of the XML. Okay. So attributes. So for example, 101, Mr. Prasad is author, title is Informatica book, and generic price is, for example, $10, published date from 1985. So description, this is for beginners. So this is the information. So information is different. So here XML generator transformation only takes the information from source. So based on that information and based on the structure of XML file which created on XML generator transformation, so it generates the source code, XML source code. This code provided to XML parser transformation input port. So XML parser transformation input data input port only gets XML source code. It understands the XML code based on the structure of the transformation which created on XML parser. So it extracts the information from source code and it provides to target. So here I just take the target as also XML file, but no problem, you can take the target as a relational table also. So that is the thing you have to understand. So main importance of the generator transformation is it generates XML source code. That's it. And XML parser is it understands the XML source code and provides information to target, any target. Information means not a XML structure and not a attributes. It only data. That is different. It extracts the data from the source code. So that is the importance of the XML parser transformation. So clearly observe this. Right. So it is valid. Now I want to create one workflow for XML. See, XML parser and generator. This is the task here, and link here, edit, mapping connections, source. For source it's a E drive, Prasad folder. And by default the file name is data.xml but it is book.xml. Book.xml, and the target is same here. E drive Prasad. Just apply and okay. Save this. Start task. Succeeded. So clearly observe here in the E drive, Prasad folder, book 1. Just open with Explorer. So always XML files open on any browser only. This is the data. Understand? Right. You clearly observe this. For example, if you want to load the XML source code to any relational database table XML column, then you have to use XML generator transformation. So generator transformation provides only XML source code. It generates only XML source code. So this is a single port. So from the data output port, we can move this to our target relational table, single XML port, single XML column. Okay, so that is one scenario. And one more thing is, for example, if you have a source table Oracle, in that particular table, any column, XML column, single column. So there is a XML source code in the single particular relational table. So you need to take that particular code and generate the data to target any relational or flat file or any XML. So in this scenario, you need to take XML parser. So XML parser only can understand the XML data. XML code accepted from relational table XML column and it would put in the XML parser. Based on the structure of the created transformation, it understands the source code and extracts the data from that, and finally it provides information to target, any target. So that is the thing. So XML is also completed. Up to today's class, all the transformations are completed except one transformation. So that is update strategy transformation. So this update strategy transformation we can discuss in slowly changing dimension type examples, type 1, type 2 and type 3. Before going to start the slowly changing dimension examples, you have to study this data warehousing concepts, dimension table, complete dimension table information. In the data warehousing concept PowerPoint presentation, I specified different number of rules to store information, complete historical and current data in the target dimension table. So if you want to store complete historical information, you need to follow some different 8 or 7 or 8 rules. You need to specify SID column. So SID is a primary key. Source primary key should not be a primary key in the target warehouse table. And you need to take one flag column to identify the new or old record. And you need to take one version column to identify the number of increments from the source table, each record. And you need to take one start date and end date columns to identify the duration of each and every update. So these are all the different rules and regulations when you when you storing the complete historical and current information in the dimension tables. So that is the reason here. If you know complete rules and regulations, then only we can work on this complete SCD type 1 and type 2 and type 3 dimensions. So that is the reason you have to completely study. Understand what I am saying? So up to today's class, the transformations topic is completed. Okay.
Yeah.
So here clearly observe this. So each and every mapping, beside the each and every mapping, there is a green color tick mark. Understand? Are you able to see this? There is a green color tick mark. See,
Yeah.
actually, for example, in the real time, we have two different options: check-in and check-out. You know already about check-in and check-out concept,
Yeah.
version controlling.
Yes,
So,
I
what is
know.
the meaning of this?
I mean, when you're working on something, you have to check out. But when you want to, when you have to check them back in so that another person in your team can,
Right.
has the opportunity to edit it. If they have to check out to their local system before they can
Right.
edit. So it's more like you submit and you have to submit it back.
If you are working on any object, if you forget about checkout, so what is the problem here?
They cannot check it in. I mean, they cannot retrieve it on their local.
Okay, right. The
They
actual
cannot
problem
use it,
is,
basically.
for example, we three people are working in same project and same workflow, right? So in this case, actually, I'm trying to update one field in one particular transformation, and you are also trying to same field in some other transformation, and some other person also trying to work on particular object and some other transformation. Okay, in this case, there is some confliction when you all the people working in same transformation at same time, right?
Yeah.
Understand or not?
Yes, yes.
So that is the reason whenever you want to work on any object, you have to check in first. So if you check in this, anybody others open the particular object, that is only read-only mode. So they cannot edit the particular object. If they want to edit any object, you have to check out. So if you check out only, then there is permission to edit to others. So if you check in, then there is no permission to edit others. Understand?
Yeah.
Right. That is the reason you have to do this. For example, here clearly observe. Versioning. Check in. So you have to write some comment. Just okay. See, the tick mark is cancelled. There is no tick mark this.
Right.
So clearly,
So every time there is a tick mark, that means you have
if there is a tick mark,
checked it out.
then it is check in. If there is no tick mark, then it is check out.
So,
So
Prasad,
clearly,
I have a question. So now, for example, if you want to delete a mapping, sometimes there might be a problem where you cannot work on that mapping. It has a problem. You want to probably redo that mapping. So what I have done is that I go into version history and then purge object. I'm able to delete it through that. Is that the best way, the only way that we can, or the best way to get rid of a mapping, of a particular mapping, and if you want to find out in a different way? Is that the
so instead of deleting the mapping, if there is a problem in the mapping, instead of deleting the mapping, just correct the problem. So that is the better thing.
Right. I got it. Yeah, you can correction will be there, but in case it is more than the correction, you want to redo it for some weird reason, right? For some reason you want to just redo it, right? Purging object, is that reliable? Because I noticed I tried that before and it would delete that mapping from the folder. Not
Actually,
just but done.
That is not the proper way. Deleting is not the proper way. For example, that particular mapping is very important to others also. For example, you created one mapping. So that is very important to me. So based on that mapping only, I am creating one more mapping.
Right.
My mapping is depending on your mapping. In that case, if you delete that particular mapping, so what is the use of my mapping?
Exactly. There will be lots more errors. I mean,
you don't need to create it. Just you have to rectify the problem. So what is the problem there? How can we solve this problem? That is the only thing, the better way you think. Okay.
Yeah.
And sometimes there is no permissions for you to delete anything from the repository. So based on the permissions only we can work here. For example, administrator provides the permission to create the mapping only, then you can create the mapping. If you have a delete permission also, then you can delete. Otherwise, you can't do it.
Yeah.
Understand? If you have a delete permission, so when the complete project in the production, so if you delete, so there is lot of problem occurs,
Correct.
right?
I don't think they'll give us delete permissions. I mean, I don't think admins will give us the permission to delete because everything is interlinked.
Whatever you want to do in the repository, then you have to you take the permission from the administrator. Then only you can do it. Otherwise, you can't do.
Yeah.
Understand? Right.
Yeah.
So we can, for example, this mapping is already in check-in. So check-in means somebody is working on this. So for example, I'm working on this particular mapping. Of course, at the same time, you also have some requirement to work on this mapping. In this case, who is working on this mapping? What is the problem here? So all those things you need to see here. So just right click on this particular mapping, versioning and view history. Here, object name, this is the mapping, group name, so on which group it is working, object type, so we have different type of objects, source table, target table, mapping, maplet, and workflow, and session, all these are different types of objects. Okay, here object type is mapping, and here the version is 1. For example, I just edited this particular mapping number of times. So version always increments. Understand? So version is used to identify the number of updates of any object. So timestamp and active status. So it is in active. So I just use it to edit this particular mapping. Version comment. For example, I want to change so and so column data type, or else I want to corrupt some so and so logic here. So that is the message here. So based on that particular version comment, others can understand what's happening there. Okay. So folder name, username. Username means everybody has some username. So for example, I just log in as a administrator. So that is the so and so administrator is working on here. So you can understand that. Understand? And host name. And host name means computer name. So on which computer the person is working on the particular object. So all these are used to identify the problem from there, and who is the particular person is working on here, and what is the object type, and what is the comment, and that means the purpose of the editing option. So all these things we can observe here. Okay. And for example, my editing is completed. Now you want to take. So just if my editing is completed, I want to check out this. Just check out. So here also check out. Okay. So that means here there is a green color tick mark option. Again we can see view history. See. Checked out. So mapping one time updated version. Okay. So active. Understand?
Yeah.
For example, we can compare with previous version and present version. That means, so if you change anything, then you can compare. Of course, without any changes, I just used, that is the reason here. So no difference found. Everything is same. Okay. So summary, mapping level difference, instances level difference, variables level difference, target loader, everything we can observe here.
Okay.
The previous editing and present editing. Okay. You understand? And one more thing is, see here, this is the joiner mapping. Here, for example, in the target column, target table column, I have a wrong data. So wrong data is loading to target table column. Okay. So for salary column, so you have to check this column's logic only from this column logic. So remaining all columns, the data is correct. There is no any problem. So in this case, if you want to track the particular column only, if you want to track that particular column only, then so clearly observe, right click, select link path, backward. Backward means we are already in the target table. So from here, the logic should be in the backward direction. So backward. When you click on this, automatically see the arrow keys are in selected red line. So you can track this. So here, is there any logic on particular joiner transformation? Is there any logic on source qualifier transformation? Or else is there any logic on source? So we can track this, and through this red color link, and we can change the particular logic only. For example, some columns depends on some other different other columns also. For example, one column is depends on 3 or 4 columns. In this case also, you can check the all columns. For example, see, this is the transformation. Clearly observe. Here, this transformation is stored procedure to calculate the total salary. This total salary depends on source, salary and commission. So just see backward. When you select this from target, so this is only column from target, T cell. From stored procedure, it depends on sal and T cell, commission, both. Understand?
Yeah.
That means the total salary, the logic is calculated on salary and commission, these both columns. So addition of these both columns only, finally you will get the answer to total salary. So the logic is depends on this stored procedure. If you have any problem with this transformation, then you can correct from here. Understand?
Yeah.
So you can track from this. For example, you want to check from here only. So we have a backward option, forward option, and both. For example, if you have to use forward only, so from total salary stored procedure to target. So this is only the forward direction. So you can check here only. For example, only backward. So you can select from here only. From both directions. Both. When you select, so from top source to target, you can track this. This is very easy to track the particular columns logic. Okay, it's very important in target real time. Sometimes enhancement projects or supporting projects is there on Informatica. That means the project is already developed. So in the production it is running. So in some particular workflows, when these workflows are loading, the data is wrong data is loading to some different columns in particular table. So you have to check the logic, and you have to correct that, and you have to load particular columns correct information. So that is the reason you need to track only that particular column. So no need to change the other columns logic. Understand? So in this case, you will track through this link path. Okay. So actually, this is one mapping. Okay. So I want to create one more pipeline here. So clearly observe this. From source DPT to DPT, and here I want to create one DPT in the target also. Right. So target table DPT DGT also created. See, clearly observe here, actually this is only one mapping. in this particular mapping, I created two different pipelines. There is no any connection between these two. Okay, I just created two different pipelines. One is from EMP table to target EMP table, and another one is from DEPT table to target DEPT table. So both are different mappings actually. So different pipelines in single mapping. Understand? So when you run this mapping, which one will start first? Which mapping starts first and which is next?
The one on top.
Sorry?
The one on top, EMP, I mean employee.
At same
I
time?
think both of them will start together.
Okay, you can create one with it. See, mapping connections. Source, system source, and DPT also from system source. And we have target. We have two targets, SR and EMP for DPT. Just apply. Okay, right. So start us. Running. Succeeded. So clearly here EMP table, that's our target. Okay, next DPT. So DPT. So by using single mapping, so we just load the data to two different targets in two different pipelines. So my question is, when you run this workflow, so which pipeline starts first and which is next? See clearly, this is depends on the target load plan. So we have option here, target load plan. See here, EMP, this is first, DPT, this is next. For example, if you want to load, DPT is the first, then you have to move to up.
Right.
So now, DPT is first and EMP is next.
Right.
Understand? The load plan means we can use the order. So here, whatever the order is available in the target load plan option, so that particular order only, that source tables will run first initially. So here DPT is the first table. So first DPT target table loads the data and then EMP table loads the data.
Yeah.
So both is not at same time. Understand?
Yeah.
And
Okay.
one more thing is next we have to start these two update strategy transformation. So before going to start this transformation, you need to check the logic of the SCD1 and SCD2 and SCD3. So first of all, what is SCD and what is SCD1? What is SCD2 type and what is SCD type 3? So these are all you have to know initially. So by tomorrow class, first you need to study the data warehousing concepts. In the
Data warehouse
concepts,
concept.
particularly you have to observe number of rules. We have 8 rules, I think, to store complete historical and current information in the dimension table. and then slowly changing dimensions type 1, type 2, type 3. So what is the logic for type 1, what is the logic for type 2, and what is the logic for type 3? So these you have to understand. So then you can easily understand the logic in the mapping level. Okay?
Yeah.
So I'm stopping the class here. So tomorrow at same time we can start.
Yeah. Prasad, is it possible for you to share that
Data? Which data?
for the tables?
Flat
Like
files?
the customer data and
Okay, no problem. I'll
those
share
data.
through email.
Yeah.
Yeah. Like, tomorrow at same time.
Yeah. Okay. Thank you.
Right.
Yeah.